Hi, this is Professor Bergstrom, and I want to talk to you today about ME1800. Now, ME1800 is probably the most important class that you will take at WPI. I fully admit that I might be biased. An aero professor might tell you that fluid dynamics or thermodynamics is the most important. The math guy might even say it's calculus. Everybody does have their own bias and their own opinions. But in my opinion, my bias is correct. And if you know me, you know that I am extremely passionate about manufacturing. I'm passionate about making sure people understand manufacturing, especially people who think they're not going to be manufacturing engineers when they go out to the industry. It's my mission in life to make engineers that understand how things can be made so that they could then go design things that can be made. And in ME1800, we're going to strive to bring you to that level, at least move you along the path. Now, 25 years ago, as a super senior, it was my second year as a super senior. 25 years ago, I took ME1800. And I was super excited about the class. I expected to take the class and to immediately be able to go into the manufacturing labs here, to go into the shops, and to be able to make anything that I wanted, anything that I could envision. I figured I could make it. I was one of those kids that had 57 different MQP ideas, and they were all great inventions, things I was going to bring to the world. But of course, I didn't want to do any of them as my MQP because then, gosh, WPI might own the patent, and I would be screwed. Well, that's actually not true, and you should look into it if you have any of those good ideas, because WPI doesn't rob you. They're actually one of the most generous universities that I've ever encountered for intellectual property. But at any rate, so I was so excited about the class. And I wasn't a very good student. I got bored quickly. Fell asleep in lectures. Never wanted to do homework. Some of you may be resembling these comments. I don't know. But, I got a C in ME1800. And the C may have been a gift from the professor. I think that it's possible he didn't want to see me come back. And so I didn't get as much out of the class as I should have. I wasn't able to just go into the facilities and make everything I could envision because I didn't put in the effort. I didn't put in the work. It was my fault. I understand that now. But what I did get was I got my first real exposure to manufacturing. I got my first exposure to manufacturing engineering, and this has become my life. I mean, it's actually amazing how the world changes. Now, I want to talk a little bit about the class and the class structure. Whenever I take over a class or when I start teaching a class, one of the first things I do is I study the course description. Because I feel like the course description is a little bit of a contract between the professor and the students. And if you signed up for the class because of what it says in the course description, I want to feel that I'm delivering that stuff to you. And if you've looked at this one recently, you may note that it has a lot of words. And in fact, it has a lot of multiple syllable words. And they seem to have been organized by a committee and put together here. And But first and foremost, it's a class about manufacturing science and engineering. It's, this is WPI. We like our TLAs, our three-letter abbreviations or three-letter acronyms. So in the class, we're going to talk about CNC. That's Computer Numeric Controlled Machining. We're going to talk about CNC machining. And in fact, we're going to do some CNC machining in the class. In the class, we're going to talk about CAD, Computer-Aided Design. We're going to use CAM, Computer-Aided Manufacturing, or Computer-Aided Machining, depends on who you ask. We're going to use CAM software. The CAM software is really the tool that we use to go from the CAD, the art that the designer prepares, to the finished part. And so the CAM software is the tool that we can use to go from our vision of what we want to make to something that we've made. Now, We're going to talk about prototype part manufacturing, and we're going to talk about this because that's primarily what we do in the WPI manufacturing labs. We help with project work, we help with class work, and it's a lot of one-off prototype kind of parts. We're going to talk about process analysis, engineering design, materials science, dimensional and surface metrology. We're going to talk about, well, there's classwork. There's a laboratory experience. In the lab, we're gonna talk about different process variables. We're gonna see how they affect performance and part quality. Did I mention that this is a class about manufacturing? In fact, the word manufacturing appears 5 times in the course description. It's a class about engineering. It's an engineering class. For a lot of the students in the class, this is your first engineering class. It's a class about science, and in fact, you can't be a good engineer unless you can understand the science. You have to be, you kind of have to be a scientist in order to be a good engineer. And I'm really excited about the class, if you haven't figured that out yet. And as I mentioned, I strive to create engineers who understand how things are made, so that when they get into industry, they'll be designing things that can be made. And it's amazing. As we get into the class and we're talking about these things, I'll tell you stories about millions of dollars worth of mistakes. In fact, I had a friend of mine once tell me, he said, "You're not really an engineer until you've made $1 million mistake." And okay, I might really be an engineer, but hey, shit happens. So we want to make engineers that understand how things are made, so that they can make things that can be made. For more information about the class and the labs and the lectures, all the syllabus, the schedule, all that resources are at ME1800.com. And just before I end this video, I just want to sort of talk about the parts that we make in the lab. We manufacture this thermoacoustic engine. The way it works is you put some heat here at this end. It heats up the steel wool, which becomes a heat exchanger inside this little test tube here. Now, if you had that aero class, if you had thermodynamics and heat transfer and all that stuff, you'll know that the air expands when it gets hotter. As the air expands, it pushes this piston out of the cylinder because there's a hole from the cylinder, from the test tube here to the cylinder. As that happens, it actually pushes the piston out. As it pushes the piston out, the hot air rushes through that small hole into the cold side here. The air cools down and contracts. It pulls the piston back in. If we've made all the parts correctly and we've sized everything right, this will oscillate back and forth at about maybe 1,000 cycles a minute or so. And it'll oscillate back and forth. It builds a little standing wave pattern. Now, for this to work, though, the piston has got to be small enough so that it can slide in and out, right? It's got to be able to fit in that cylinder. But it's got to be close enough to the size of the cylinder so that, well, right now I've just plugged up the hole with my finger, and the vacuum that it's creating is holding that piston in until I pull my finger off and the piston falls out. There's about 6 or 8 10,000ths of an inch difference between the diameter of the piston and the diameter of the cylinder. And so in the class, you learn how to actually make these cylinders and make these pistons so that they work together. You get to assemble all the Stirling engine here. You get to manufacture the components and do all those things. So it's really an amazing class. We don't have to call it Grunge Lab anymore like they used to when I took the class. You don't have to get dirty in the class. In fact, if you want to get dirty while you're doing the class, you're going to have to try pretty hard. So we won't have to call it Grunge Lab anymore, although you can if you want to. For more information about the class, again, go to ME1800.com. There's info about the labs, lectures, syllabus, schedule, resources, all that stuff. There's videos of the thermoacoustic engine running, and I look forward to seeing you in class.